So welcome everybody. Our task name is Emotion and Theme Recognition using Jamendo, and my name is Tovstogan, and I have Dmitry Bogdanov with me, and we'll present the overview of this task. So, as the title suggests, we want to understand emotions and themes in music. And in music information retrieval, it is a very popular topic. It's called music emotion recognition, MER. There is a lot of paper, a lot of research being done there. And for the MediaEval, before, we had the music emotion recognition task that was run for 3 years, I think. And they were focusing on the arousal valence values of the emotions. And there is also a task in the MyRex, if anybody knows, very also long-standing task trying to recognize the emotion clusters from 600 audio tracks. But the new thing that we want to introduce is this concept of themes that are things like when you hear the word like epic music, you can understand what kind of epic music means, but it is not a mood per se or emotion, or like dark music. It has some connotations with the emotions, but not directly, or Christmas like some kind of context. So we want to add these kind of annotations to our dataset and explore it. So Jamendo is the company that provides the Creative Commons music for people to play in the stores, to use in the videos. They have a lot of ways that you can discover this music, and they position themselves like royalty-free music for commercial use. And here, like, you can see some examples of, like, you can go like by genres, themes and moods, instruments, languages, and we want to focus on the themes and moods. And there are some kind of clusters, and these are the notations that we'll be using for our dataset. So we have introduced a dataset called MTG Jamendo dataset that had been presented this summer in the ICML conference, and we have more than 55,000 audio tracks that are available to download and to the process. We have almost 200 tags that are spread between like 3 categories: genre, instruments, and mood and themes. Moods and themes are the focus for the MediaEval task, and we did some pre-processing, and the idea of this dataset is that it is good quality because the music is uploaded to Jamendo and it's curated by the company to ensure the basic level of the quality, and the tags are also uploaded by the artists, and the tag quality is also ensured by the Jamendo, so they are doing a bit of the post-processing, as you would say. And when we were preparing this dataset, we also did some pre-processing for the tags, like merging the tags that basically mean the same, like sadness and sad, into one tag, so the quality is even higher. Let's focus on the moods and themes. So here you can see like all of the 56 different tags that are moods and themes that we have in our dataset that we provide for this task. It is more than 22,000 tracks, and it is kind of unbalanced, but it is natural. You have a lot of tags that are like happy, film, energetic, and so forth, and you have like less tags like cool, powerful, hopeful, that it is a bit more ambiguous ones. And we have filtered the tags that we have the tracks. The tags is represented by at least 50 different artists. So we need to ensure like the diversity of the data for one tag. And but if we disregard it, there are a lot of interesting tags that are potentially interesting for the research, but in the context of this task, we just like disregarded them, like ethereal or water, like not sure what that means. But and another important question is that people might ask, what is the difference between mood and theme? So it is kind of a bit more subjective and perceptual, but the important thing is for this task, we don't make any distinction between those two, so they're just like together. But it is a question for everybody to ponder about, like deep. Is it a mood or is it a theme? Like you don't really feel deep as the mood, but soft or calm, it may be a bit of the mood, like calm mood, of course, but soft, is it mood or theme? So yeah. This is basically the summary of our task right now. Goal is automatically recognize the emotions and themes conveyed. It's important part of the task goal in the music recording using machine learning algorithms. the novelty. We have themes that are interesting addition. We have a new open dataset with good quality of the text and audio. And the audio is available under Creative Commons license. Everybody can download them and play around. So we have some examples. So I will ask you to tag the tracks with the moods and themes categories. So let's play the first one.
The sound setup does work, so we have to play it here and you should listen.
So yeah.
Example number 1. What's that?
Melancholia, anticipate, dark, dramatic, ominous. So the ones that we have from there is melancholic. So somebody was right. It is also tagged as a melodic, sad, very kind of obvious tag. And the next example.
Example 2. What's that?
Halloween, spooky, futuristic, psychedelic, space. For me personally, I think it's the most descriptive tag. Emotional. It has been tagged as emotional. It has been tagged as documentary.
As a use of this potential use.
Yes, so it's kind of a bit of the context. So also think about like themes, like not only the moods. And the last example. What do you think? Commercial. Happy. Wake up in the morning. Advertisement. Commercial. Corporate. Happy. Motivational. So this one was a bit easier for everybody. So yeah, as you see, this task is not very easy, even for humans. So that's kind of an interesting part of the task also. So Dmitry will continue.
So you have put it incorrectly as well. Okay. So now let's continue with the second. So I'll continue the presentation. So as we said, the entire data is for generic auto tagging. So you can do other tasks as well, but for the purposes of MediaEval, we focus on emotion and theme. So that subset has over 18,000 tracks. And we provide all those data in these 56 tags. So what's interesting, the audio is in high quality. We can provide the highest quality possible, but we decided 320 kilobit per second MP3s, which is a decent high quality. Because many tasks in music auto tagging, they utilize very low quality data sets, and maybe that's important because they only provide you a segment of 30 seconds, and that segment may be only 60 kilobit per second, so it doesn't actually represent how the music sounds often. So apart from that audio, that was a challenge to download for some people maybe. So we also thought that the most typical way how you would run an auto-tagging system is to have spectrograms. And the most common spectrograms in music information retrieval nowadays are MEL spectrograms based on MEL energy bands. So in this case, we provide those as well as NumPy binary archives. And a part of that, if you remember, previous years we had acoustic brain's Jamendo Task, so it was based on handcrafted features. So we took all those features and computed them for this task as well. So we kind of linked the previous task to this one in this sense. So we have done some pre-processing of the data. So for example, we only use the tracks that are at least 30 seconds long. We also have merged together some tags that were referring to the same concepts or were mistypes, misspells. For example, Spanish guitarra will be mapped to guitar, and this way we don't have redundancy. That is also common in other datasets for auto-tagging in music. So once we got all that, so basically the submission process allowed participants to send us 5 runs. And the metrics are computed based on the following. So we ask participants to provide us tag activation values. All participants used deep learning approaches, and in this sense they all have the activation values. Based on those values we can compute ROC AUC and precision recall AUC, which is our main metric of choice, but also we ask them to quantize those activation values into decisions, so to say if a tag is present in a song or not. And for that reason, we also use F-score, precision and recall. Oops. So now we provided a basic baseline. This is inspired by, from image processing. So it's a 5 layers convolutional neural network where you have very small filters, and it's a typical baseline that we use in music information retrieval for auto-tagging. I think I'll skip the details here, but what is interesting, we could check, for example, the worst and the best tags. It could work, and for example, it could cope with some tags like deep summer, film, corporate that you all recognized as well. And those tags has a lot of representation in terms of tracks. But if you check the worst tags, some of those really lack maybe more examples to train systems, but some others are still having pretty much examples like drama or movie. So these are complex tags that are very difficult maybe to predict. The good thing that we can then do this type of per tag analysis, and so we had 8 teams and they proposed 27 runs, so we evaluated all of that. And here are the titles of the working nodes, and if you see, they all have words like convolutional neural networks or convolutional and recurrent neural networks. So that was the theme for the topic of this year for us. And also there were some tasks trying something else, like adding self-attention or doing specific variants of CNNs. And also some teams worked on data augmentation and on using transfer learning, using pre-trained models existing in other audio analysis domains, or fusing together different models as well. So the results are presented here. So we have the baseline that was pretty basic, but it's interesting that there's not much improvement that could be done by many submissions over that. Well, it was basic, but it was state-of-the-art kind of. At the same time, the leading submission really got some extra boost. I think we are really happy with that, and in general we have some nice submissions. What is interesting is that, so to beat the first leading team, that is JKU, if the rest of the good teams join together into a late fusion, for example, we could actually surpass all their work, merging all that together, but still be a bit short of the JKU. So guys, I mean JKU, we have to beat them, but maybe next time. Here is a plot of precision and recall, as just to check how it mapped, and one particular team had all kind of abused the recall too much while having kind of an average precision. The conclusions is that the task is challenging. In fact, it's more challenging than a typical auto-tagging task in music information retrieval, where you would use more easy tags to predict, such as genres. In this sense, when we started working and providing investment, when we saw the result, it was okay. So it's a really low PR AUC, but that's okay. So we will work with that. And there was some improvement in this year, so this is nice. Yeah, there were some architectures that work pretty well. Maybe the dataset is not large enough, and for that reason, some teams used augmentation. Just want to highlight the future directions that we could do, and this is basically for we would like to run that task again. Maybe we should consider instead of tasks also have a subtask where we map those tasks into arousal valence values, so we can have a regression task for predicting arousal and valence. We could consider improving the balance of the tags in this data set and force teams to provide individual tag analysis so we can really see what types of music they all kind of perform well and what's the difference between their approaches. We have also the additional part of the MTG Jamendo dataset that we didn't use, and it can be also used. So yeah, everything is completely open and reproducible, Creative Commons, so it's super transparent. So I think that's not often the case in our domain, at least. Yeah, and that's basically it. So if you have questions, let's talk.
Thank you, Dmitry and Philip.